aim to determine the frequency of AC mains with a sonometer and a horseshoe magnet apparatus. A sonometer, horseshoe magnet, step-down transformer, a wire of non-magnetic material, digital valence and slotted weights. It can be either digital valence or physical valence. Theory: frequency of AC mains F is equal to 1 by 2L multiplied by the whole root of T by M, where T is the tension in the string, L is the length between the knife edges or wedges for maximum vibration, and M is the linear density of the wire. The apparatus needed here are a digital valence, a step-down transformer which should be set up at a 6 volt, slotted weights, a horseshoe magnet, plug key, rheostat, meter scale, connection wires, a sonometer and a non-magnetic wire of 155 centimeter length. These two are the wedges of the sonometer. This is a paper rider which should be kept over the stretched wire of the sonometer. Measure the mass of the string. It is 1.8 grams. Observation: mass of the wire M dash is equal to 1.8 gram is equal to 1.8 into 10 to the power minus 3 kilogram. Length of the wire L is equal to 155 centimeter is equal to 155 into 10 to the power minus 2 meter. Linear density, mass per unit length, M is equal to M dash by L is equal to 1.8 into 10 to the power minus 3 divided by 155 into 10 to the power minus 2 is equal to 0.00116 kilogram per meter. Knot the non-magnetic wire through this small hole, tie it securely and pass it over the wedges and pass it over the pulley over here, and at the end here you have to tie a small knot on which the weighted hangers can be suspended. The connecting wire to the lower terminal of the rheostat and connect the other end to one end of the stretched wire which is stretched over the sonometer. Connect a connecting wire to the upper terminal of the rheostat and this is a step down transformer, so you have to set it at 6 volt and connect it to one terminal of the step down transformer. Connect the connecting wire to the other terminal of the step down transformer and then connect it to the other end of the plug key, to one terminal of the plug key. Now from the other end of the terminal of the plug key, connect with the help of a connecting wire and connect it to the other end of the wire that is stretched over the sonometer. This 50-gram weight into this slotted weights, so that now the total mass of the suspended weights is around 200 grams. Keep the paper rider at the center of the meter scale, that is close to 50 centimeter. So you can see a paper rider has been kept. Keep the horseshoe magnet above it, so that now the horseshoe magnet and the paper rider are in between two wedges. Keep the wedges at a close space, then switch on the step down transformer, which is kept at a selected voltage of 6 volt, and then gradually increase the distance of the wedges and find the resonating length. So here we can see that the resonating length can be found by slightly increasing the distance. You can see that the paper writer has started to vibrate slightly. Now the paper writer has started to vibrate. The vibration is becoming stronger, and the rider has fallen down. So now you can note down the readings of the wedges. Here the wedge is at 32.5 centimeter, and here it is approximately at 72.3 centimeter. Now for the second set of reading, you have to keep the wedges at a far away distance. So now the wedges are kept further away from one another, and you have to switch on the step down transformer and then find out a resonant length by bringing the wedges close together. So you can see that now the resonating length can be found out. The wedges have started to move inwards, and the rider is vibrating slowly. Now you can see that the paper rider has fallen down, and this is the vibrating length. So the distance noted here for the first wedge is 31 centimeter, and here it is 69.2 centimeter. When a load of 200 grams was suspended, we have to now convert it into the tension in newtons. So T is equal to mg. So 200 into 10 to the power minus 3 to convert it into kilograms into 9.8, which will give as 1.96. To find the resonating length when the wedges were kept close and then increased, the first reading was 39.8, and when the wedges were kept far away and brought together, that means when the length was decreasing, we got 38.2. The mean of these two readings is 39. To find the frequency for this resonating length, we have to put these values in the formula. F is equal to 1 by 2L multiplied by the whole root of T by M. That is 1 by 2 into 39 multiplied by the whole root of 1.96 by 0.00116, which gives an answer of 52.6 Hertz. Add another 50 grams to the slotted weight, so that now the total mass hung is 250 grams. Switch on the step down transformer, which is kept at a selected voltage of 6 volt. Now the wedges are kept close. Increase the distance between the wedges and find the resonating length. You can see here the distance between the wedges are increased. Now the mass kept is 250 grams. Now it has started to vibrate and it has fallen down. So now you can note down the readings. It is 30.7 centimeter for this wedge, and here it is 74.8 centimeter. Switch on the step down transformer. Now the wedges are kept at a far away distance. Now move the wedges close enough and find the vibrating length. Now you can see the paper rider has started to vibrate slightly. Now it has fallen down, the paper rider has fallen down, and you can note down the readings between the wedges, and here it is 28 centimeter, and here we got a length of 73.7 centimeter. Now 150 grams was again added. Now the total weight suspended is 250 grams. Now we get for tension 250 into 10 to the power minus 3 into 9.8, that is 2.45. The first resonating length when the wedges were increased is 44.1 centimeter. When the distance between the wedges were decreased, we got 45.7 centimeter. The mean of this two readings is 44.9 centimeter. Substituting these values in the formula, we get an answer of 51.17 Hertz. Add another 50 grams loaded weight into this one. Now the total mass suspended is 300 grams. Switch on the step down transformer. Now the wedges are kept at a closer distance. Take the wedges far away from one another, gradually moving it away from one another, and find the resonating length. Now it has fallen down and you can see the reading between the wedges. Here it is 27.5 centimeter and here it is 77.3 centimeter. Switch on the step down transformer. Now the wedges are kept far away. You have to move the wedges inwards and find the resonating length for the mass of 300 grams. You can see there are very minor vibrations. Now there is a strong vibrations. And the paper rider has fallen down. So here the reading is 25 centimeter and here it is 74.5 centimeter. When again a 50 gram weight was added to the slotted weights, we could see that now the total mass is 300 grams. To convert into tensions, 300 into 10 to the power minus 3 into 9.8 is equal to 2.94 Newton. The resonating length when the wedges were, the distance between the wedges were increased to 49.8 centimeter. When the distance between the wedges were decreased is 49.5 centimeter. The mean of these two readings is 49.65 centimeter. Substituting these values in the formula f is equal to 1 by 12, the whole multiplied by root of t by m, we get an answer of 50.6 Hertz. To find the mean, we take 52.6 plus 51.17 plus 50.6 divided by 3. So here we have taken 3 readings, so we take the mean of these 3 readings, which we get 51.45 Hertz. Result: the frequency of AC mains by experiment has been found as 51.45 Hertz.